Hand blades asks this question. I'm watching MythBusters episodes, and I'm pretty sure I caught your first on-screen disagreement with Jamie in the chicken launcher. The myth. In regards to your air tank selection. Okay, so just to give some context, the chicken launcher myth comes from a really great urban legend about the US military testing the efficacy of their airplane windshields to survive a bird strike by building a cannon to fire birds into the windshields at speed, like 400 miles per hour, or whatever the reasonable miles per hour that the plane would encounter. And the myth is that the Americans did this to test their windscreens, and the Brits wanted to do it, or some other country wanted to do it, and kept on just sending the birds all the way through their windscreens. And they couldn't figure out, they were using all the same parameters, same type of cannon, same type of speed, same type of pressure. And they wrote to the Americans and said, why is this, why are our birds going right through the airplane rather than bouncing off the windshields? And the Americans said, thaw your birds. So they were using frozen chickens, apparently. It's a funny story. It's a good story. And it begs the question, if you are sending a 5-pound object, 10-pound object at 400 miles an hour, does it really make a huge difference if it's frozen or thawed? And that might seem like intuitively, absolutely, it's harder if it's frozen. But remember that water resists impact in direct proportion to the speed of that impact. That's why when people successfully jump off the Golden Gate Bridge, they often pull them out in pieces. I'm not kidding, it's gruesome how much damage water can do if you hit it wrong from a high height. So we decided to investigate this, and we built our own chicken launcher. The least safe object we ever made on MythBusters was the first dangerous one, I think. Handblades continues. The thing that struck me about this was while you were often portrayed as a goofy guy opposite Jamie's straight man, you were way more concerned about safety than he was. Why? Well, was that mostly the case over the years? He seemed much more cavalier about it and seemed to be a recurring thing the more I'm watching. No, Jamie is not cavalier about safety. He might be more cavalier about his own safety. That's his prerogative. He is not cavalier about safety. I'm just going to state that blanket. And like all of us, he might be more cavalier about his own safety than anybody else's. But no, the two of us felt highly aligned in the safety parameters we created in general on the show. I'll state that full stop. The difference between us is where we do and don't trust our intuition, which is kind of fascinating to me because there are very different ways in which the two of us trust our intuition. Jamie will never let his intuition get in the way of the right solution, by which I mean he really does start from well, could I execute a solution with boogers and tongue depressors? And then he'll just try that. He won't throw out any solution as stupid until he's tried it, which I think it speaks incredibly highly of him as an engineer. That is I'm thinking about building something out of aluminum or steel, and I need a little more hardness, I'm gonna go with steel. And he's just gonna really test it. If lightness is important, he's gonna test it out of aluminum, see if it's hard enough. So, and we had one huge argument over this, and I'll get to this in a second. But so, like I said, Jamie was unwilling to let his intuition about how things worked guide him to a solution because he always did these practical executions. If I would not do something because I thought, this is going to take too much time, that's exactly the kind of thing Jamie would try. And our joke, we told this joke a lot, was that given the same amount of time, Jamie will spend 70% of that time making drawings and end up with something that works. And I'll use that time to build the thing 4 times, but I'll end up with one that works. We'll both get to the same place, but he does a lot more of this mental work and a lot more testing, and I'm just build, iterate. But when Jamie knew something was going to work for his satisfaction, he didn't need to know anymore. And one example was we were trying to figure out how to send ping pong balls down to a boat 30 feet underwater to raise it with ping pong balls. This was our only myth that came from Donald the Duck comic book. And we were, so how do you take what would end up being 20,000 ping pong balls and get them 30 feet underwater? How do you do that? We had all these ideas, like a chain-driven thing with hooks that pulled them down. Jamie and I sat down at a whiteboard and spent probably 2 hours drawing up different ludicrously complex solutions, back and forth, back and forth, back and forth. And then Hyman was like, wait a minute. And he thought this. He thought, if I have a hose that can transport a ping pong ball, and I fill it with water, and I put one end 30 feet underwater and one end at the surface, if I pour water in the top, it's going to come out the bottom, right? Like, that's a fait accompli. So if I put a ping pong ball in there and I put water on top of it, is the head pressure of the water on top enough to drag the ping pong balls down to the bottom of that tube, right? Is that a cycle you can create? Or will the buoyancy of the ping pong balls just stop your water at some point? So we set this up on the roof of M5, which is 22 feet from the railing to the ground. And we set up a tall pipe and we put the thing in, and it worked at 22 feet. And I said to Jamie, I'd really like to get a little bit higher and make sure it works at the depth that we are going to execute. And he was like, no need. I know it will work. And I was like, I'm not sure it will work. And he's like, that doesn't concern me. I don't think he said that exactly, but that was the vibe, right? I'm like, I would like to do one more test before we pull all of our resources and head to Monterey with the permits and everything and do this. I would like one more test to be sure. And he was like, I don't need it. I know that this will work. He was right. And I think in that argument, so was I. These are two different approaches to engineering. But that's how he would use his intuition. Like, once he understood that the thing would work for parameters, he'd bet his life on it. The biggest argument we ever had over this was for Archimedes' Death Ray, the second execution of Archimedes' Death Ray, or the third? I can't remember if we did it two or three. The last. We'll call it the last execution of Archimedes' Death Ray, which we did in conjunction with the Obama White House. We went there, filmed with the president. It was spectacular, totally amazing. And we used the student body of Encinal High School in Alameda, California, where Jamie's wife was the science teacher for 20 years. We set them all up on the shore of Alameda, and we had our Roman ship, and we had 500 people with mirrors on the shore. And this whole myth, Archimedes' Death Ray, is the myth is that Archimedes set up soldiers with polished shields to set fire to incoming vessels to defeat the Romans. And the first time we tried this out, it's almost impossible to get 8 people from 10 feet away to point 8 mirrors at the same location. It's amazing how hard that is to do. 500, we're looking at, with the Obama administration, we're making a big episode because Discovery, once went to shoot with the president, they freed up some more dough. So we were going to use Encinal High School. We're going to have 500 people with polished pieces of brass, polished mirrors, really, pointed at this boat. And we needed some way to aim them. This is the most difficult thing, is to know that the beam you're looking at is your beam. So you want an aiming reticule. And a lot of people, and you might be thinking this right now, is why not make a convex mirror so that you can focus it? And the answer is a concave. A concave mirror has only a single focal point. Concavity does not work for the Archimedes Death Ray in any way, shape, or form, except collectively. And that is what 500 people do. They basically create a kind of a Fresnel reflector. But we needed an aiming reticule for this. And this is a difficult problem to solve because you can't put the aiming reticule on the mirror. It has to be somehow mounted to the earth between you and your target. And then I thought, what about a mesh fence? What about those plastic mesh fences that they use to just delineate a construction site? It's lightweight. We can get it in we can get it in white, black, or orange. And it can provide for us something that doesn't inhibit the reflection too much, but shows us where ours is. So as long as we have that reflection placed over our target, we know we're hitting our target. I thought this was a brilliant solution. Jamie agreed. And then he said, the fence should be black. And I said, I disagree entirely. It needs to be white because we need to see the reflection of our mirror in the mesh. And we're not going to have a lot of signal because we're looking at daylight. So it should be white. And he said, no, I think it should be black. And I said, okay, but what we need to see here is photons. And by definition, white reflects more photons than black. And Jamie gave me this look, which is, it's a very Jamie look. This is sort of like, you say so. Like, what he was really saying was, I haven't tested it, so I'm unwilling to trust your intuition. And I was like, I cannot believe I'm explaining to a grown man that white reflects more photons than black. But sure, Jamie, go order some black fencing. I acquiesced, and that black fencing showed up, and it was a disaster. And we had to paint it white. We had to paint mesh white, which is like gallons of paint rolling on this mesh, very little sticking. I was so happy about being right about that. But I can't even tell you how mad I got when I got that, like, if you say so, look from him. And lest you think I'm denigrating him here, I think his mindset there is magnificent. It's incredible to me that he could hold out and push away his own intuition that white transmits more photons until he tested it himself and was willing to go with his intuition that black was the right color. Like, he might have been wrong, but I really appreciate the willingness to throw out what you think you know about physics in lieu of what you're actually witnessing. Yeah, I think that's a great frame to hold as an engineer, despite it really pissing me off in that moment, and despite Jamie being wrong in that moment. I still think that is I admire, yeah. All right, I've said everything I want to say about that. And that look, oh my God, it made me so mad. Thank you guys so much for watching, and I wanted to briefly mention that you could become a tested member. I know, everybody is competing for you to become a member of their thing. What I want to express to you is that the Tested membership has become such an important part of the Tested family. We get tremendous feedback from the Tested members, and they expand the stories that we can tell and the things that we have access to. And you can become a part of it right now by clicking on the link below. See you in the chat.